Hello, good afternoon. Um, I suppose you can see my screen.
Yep.
Yeah,
It's
great,
fine,
great,
fine.
great. So, my name is Tomy Duby. I'm a member of two U3As. One of them is a local that's here in Bicester. If you don't know where Bicester is, this is where it's 10 miles north to Oxford, and where the Bicester shopping is located. That's about 20 minutes walking from here. But I'm not going there. Today I will be talking about something I think I understand a little bit, numerical computing in its widest form, and two specific examples. By training, I'm a physicist, but most of my life in physics I spent doing calculations, and I started with a pocket calculator and then progressed to Fortran. If there are some old people here, you may remember the name Fortran. And about 20 years ago, I moved to MATLAB. MATLAB is a commercial software. And then recently I discovered that it has a free clone, which is called Octave. And I will start talking about Octave in a minute. So please interrupt me if you have any questions. I will switch between softwares here as I think is required. I'm not going to presentation mode because it will confuse Zoom and my three screens here, but I will move the PowerPoint on and off from this screen as I need it. And I prefer to show you a live demo and not what I've written in the PowerPoint. You can then have a look at the PowerPoint when I finish, and this presentation will be distributed. So that's as an introduction. What is numerical computing? Well, it is when you need to find a solution of a problem that is described by numbers. In principle, I am aware of two types of numerical computing. One of them is computing with numbers, and the other one is computing with symbols, like algebra. And it is called computer algebra. And I will demonstrate a free software where you can do really very nice things. And it may help you in certain cases, and I will demonstrate one of those cases. There are some useful lists here, like list of numerical analysis software. These are links to Wikipedia, and Wikipedia has list of these free and commercial softwares. And you are invited to choose them, to select them, to install them on your computer, and to try them out if you need. So let me start really talking business, that is mathematics. The next slide is that's the introduction to computing with numbers. And the software that I will be using is called GNU Octave. Octave is a clone of MATLAB, and you can download it for free from this link. And it can do numerical calculations. That means it can number crunch. It can't do this. If you give it this example of a plus b squared, it can't decompose it or expand it to a squared plus 2ab plus b squared. Now, once you install it on your computer, it comes in two flavors. You get two programs. One of them is called CLI, Command Line Interface. That means you type in your commands, and it looks like this. Let me bring it up. That's it. That's a command line interface of Octave. CLI. You can see that in these small letters, meaning you type in here whatever you want to calculate. For example, 3 plus 5, carriage return, and it gives me the answer. Of course, that's simple, but that's how it works. You type in, it gives you the result depending on the complexity. Sometimes immediately, sometimes it needs to do some number crunching. And if you type, for example, the same command, I can recall it by up arrow, 3 plus 5. And if I type a semicolon at the end, it does not display the result, but it calculated it. So if I do, for example, x equals 4 times 7 semicolon, it calculated it. If I want to display, I just type x without a semicolon, and here is the result. Much more user-friendly is the Windows interface for it, and it looks like this. This is a GUI, graphics user interface. It looks like this. Here, you type your commands. In this window, you have the history of your commands, and here you are the variable that's you already defined. And here are all the files. This is like a Windows Explorer that are in your default directory. The default directory is this one. I will come to that a little bit later. Okay, I'll just bring in this. The next slide is the introduction of this command line interface. This is what I already shown. And here is a graphical user interface. Now, the examples that are here, I will live demo them. So that it's now, I won't talk, okay, look, 3 plus 5, I type it in. I will show that. But I will move that out of your view so I can copy or use whatever I already have there. So, but you will get it in the distribution file. Okay, so give me another example. 5, sorry, I have to do it here. Type here 5 minus 7, carriage return, minus 2. That's okay. Power exponent 12 to the second power hat 2, carriage return is 124. That's simple. What about 50 divided? So far I worked everything with integers. 50 divided by 7, carriage return. Here is a result. Well, it's a result to 5 digits. I want more precision. So for that purpose, I have to use the following command. It's called format long carriage return. Sorry, not long ng. It's happy with this. Recall the last calculation with arrow up. 50 divided by 7. Now I have it to what's called double precision, 16 significant digits. The program has also built in some constants like pi, 3.15, 14159, more I don't remember, I don't need, or e, basis of natural exponents, 2.7188281, and so on. I'm just moving to the next slide. It is also capable of handling complex numbers. You remember your complex numbers? I hope yes. So for example, square root of -1, now square root is obviously square root of a number. Square root of -1 is written in this way, 0 plus 1i. I is a square root, is an imaginary, purely imaginary unit, 1i. And to be more precise, for example, -2, there is no multiplication sign between the number and I. -2i to the second power, that's -4. Square root, second power of I is -1. I think this is what you may remember from your, well, I don't know whether you learned it in high school. I did, if not at university. Or there is another way to express complex number with using an exponent. So if I type exponent of pi times 0.5, that should give a purely imaginary number. Sorry, I forgot the I. Forgot to put the I. Recall the last command, type it I. And here it is. It's a purely imaginary number. The real part of it is pretty small, 10 to the -17. The imaginary part of it is 1. This is how it should be. If you want to recall, to specifically get the imaginary part, you just type, I will recall the last command, so that you see how can I edit imaginary, open brackets, close brackets. This is the imaginary part of that exponent, pi times 0.5 times I, and I get the 1 I had here above. So that is the complex numbers. These are the complex numbers, and how to deal with them. I can get the magnitude of a complex number. For example, if I recall the previous number, that, and write here absolute ABS, open bracket, close bracket at the end, I get its absolute number, its magnitude, or its absolute number, and that is this 1.0. And with complex numbers, I can have the absolute number and it's the angle. And to get the angle, I simply have to write, instead of absolute angle, and I get that. Well, if you don't believe that this is pi over 2, so let's convert it. This is the angle of that complex number in radians. If you don't believe that it is pi over 2, so let's simply convert it into degrees. That means I have to multiply it times 180 and divide it by pi. This is the conversion, radians into degrees. Carriage return, and I got 90 degrees. Just to show you how this works, these are relatively simple commands, not that different from everyday's language a mathematician / physicist or engineer is used to use. Any questions so far? One of the great advantages of this software is that it is very efficient in using vectors and matrices I will skip the matrices, the use of matrices to a later stage where I really need it. So if I want to, sorry, not that one, I did something incorrect here. So let's undo that one. I have to be working here. Let's define a vector. A vector, I will call that vector A1 equals square bracket 1, 2, 3, 4. What is A1? A1 is a row vector of 4 elements. The first element is 1, has a value 1. The second element has a value 2, and so on. How can I define row vectors? Yes. So I'll do it similarly. A2 equals, open square brackets, say 5, semicolon, 6, semicolon, 7, semicolon, 8, close bracket, return. You can see they are displayed here as a single column vector. Now, a matrix is a generalization of this. It has rows and columns, but I will skip that to a little bit later. If I want to extract a single element from this, I have to tell the software which element. So, for example, the third element of vector A1, this one, I will write A1, open bracket, 3, close bracket, return. Or the fourth element of A2, number 4, that's 8. Now I can do certain manipulations of these vectors. For example, I can multiply vector A1 by a constant, by a number, say A1 times 3. What happens? It will take every element of vector A1, multiply it by 3. 3, 6, 9, 12. Similarly, I can do the same on the column vector. But what is more interesting is, for example, element by element multiplication of these two vectors. Element by element, meaning 1 by 5, 2 by 6, 3 by 7, 4 by 8. And this is done in the following way. A1 dot star A2. Okay, it did something incorrectly because I was doing it incorrectly. This is not what, sorry, that's what I get. 5 times 3, sorry, 1 times 5 is here. 2 times 6 is 12 here. 3 times 7 is 21 here. 4 times 8 is 32 here. The first row is 5 times this. The second row is 6 times this. The third row is 7 times this. And the 8th row is 8 times this. Sometimes you need to do these things. Now, if you want to extract more than one element For example, you want to extract these elements. Let's start from here, 6, 7, 8. So that means you want to extract from the second to the fourth element. So let's do that. A2 from the second, colon 4 from the second to the fourth element. Let's see. 7, 8, 9. Sorry, 6, 7, 8. From the second to the fourth element. And what should I do if I want to extract only every other element? 6 and 8, for example. So I type A4, A2, brackets 2, 2, 4. Meaning, go from the second element. Sorry, I will use my cursor. Go from the second element in steps of 2 until the fourth element. Let's see.
Mm-hmm.
There is something out of bound. I tried it. Let me try it on A1. No, something is wrong here. It's my fault because I tried it. Sorry, my fault. It is my fault. I should have done it this way. Colon. From the second element in steps of 2 to the fourth element. Return, carriage return. Yeah, 2 and 4. What do I do if I want to extract a slightly different combination? For example, A2 brackets, open round brackets, close rectangular brackets, 2, 3. I want to extract the second and third element. So I write here a vector of what I want to extract. Return. 6, 7. Okay. Any questions?
I'm monitoring everyone's. If anyone's put their hand up, I can see that.
Now, simple mathematical functions. Of course, like a modern pocket calculator, like that one that Peter put in as an image with my talk, it can do trigonometrical functions, simple trigonometrical functions. For example, sine of pi over 2. That sine of 90 degrees, that should be 1. It is. Now, if I do sine of pi over 2 multiply by 2, well, that's pi. That should be 0. It is almost 0. And that is the smallest number that is different from 0 that the software distinguishes compared to 1. This is numerical accuracies, and I don't want to go there today. If I want to work with sines or trigonometric functions in degrees, then I have to do sine d bracket 90, and that's 1 of 180 degrees. That's, of course, 0. Why is this 0 and here above we had something that was 10 to the minus 16? I don't know. Now, just going one step back, what do I see here? Here are the variables I defined. I defined A1, that was a row vector, and it gives you a description, one column, sorry, that was a column vector, 1 row, 4 columns, and here are its values. A2 it was a row, column, sorry, a one column vector, 4 rows, 1 column. The values are 5, semicolon, 6, semicolon, 7, semicolon, and 8. And each time I ask a calculation to be done, it returns to me a variable called answer, ANS, with the last result. I can reuse it if I want to. And this here are my last commands, and I can highlight them. Highlight it, Control C. I will bring them in here, Control V, and it will do the calculation. So it is pretty user-friendly, this software. It can also deal with characters. You have to put the characters into a double precision, wrong, double quotation lines. Single quotations would also do. For example, T1 equals double quotation mark to be or not to be. It's close, the quotation mark, return. So it will display the result, T1 equals to this. What about if I need to extract a word from there? Well, I need to calculate the characters. So first character is T, second, third, fourth. So if I do T1, open brackets, 2 colon 3, that's 4 and 5, if I'm not mistaken, 4 and 5, it will return me B. It returned the word B. Sorry. It is happy to deal with character strings, and you can manipulate character strings. You can also concatenate that, meaning put two strings together. It is pretty happy to work with it. The next is something that's interesting. It can do integration, and I'm better now bring in this, my PowerPoint presentation.
Mm-hmm.
It can numerically evaluate a definite integral. It can't do indefinite integrals because they are formulas. It can do a numerical integration. For example, it can calculate this integral of 1 over x squared, 1 over 2x squared plus 3x plus 1 from 0 to infinity, and this is a natural logarithm of 2. And I will show how to do that. And it turns out, as you can see here, I needed 2 lines to get the result. And then I'm checking it and dividing by logarithms of 2, and it is giving me 1. So, and by the way, in my presentation, everything that is in light blue color is there because light blue, because you will enter it, or I enter it to the software by hand. So let me first of all define the function I want to integrate. And that function, I will call it fun1 equals, and I do here a trick that defines so-called anonymous function. That means it is a function that does not have a special place in your in a file. It is just defined for this one purpose. So this function is 1 divided with a dot. Why dot? Because I need for every value of the argument x do this calculation. Divided by 2 times x squared plus 3 times x plus 1. Carriage return. without semicolon. I want to see what I entered, and this tells me the function, the anonymous function called fun1 is defined, is a variable of x, and it is defined as 1 over 2x squared plus 3x plus 1. To do this integral, I need to type integral. That's pretty logical that I have to type integral. I have to type then the function fun1 from limits of the integration from 0 to infinity, which is this three characters I and F, close brackets, carriage return. Is not happy with this calculation. Why is not happy? I typed integral. Yes, I know why it's not happy. This definition is not correct. I did not do dots here where I had to do dots. So if I correct it that x dot power second power from 3 times dots, that's not Nick require. If I do return, that's better. And I do the integral. It's happy to do the calculation. Did it. Now I'm not sure whether that's logarithmus naturalis of 2. So just to check that, I take the last result and divide it by ln 2 or log 2, log 2, carriage return, and give me 1. So it calculated this integral numerically, did not complain, and the result seems to be correct. By the way, if you use this software, you better always make sure that the result makes sense.
I've got a question on that, Tomy.
Yes, please.
You've got a function there which has got x as a sort of like a variable. You've got x dot in the first x. Why wouldn't you put x dot in the second x?
I can put, but it makes no difference because multiplying by constant it does it in the same way whether there is a dot or there isn't a dot.
Oh, okay.
3 times this. We had this example before that when I defined A1 times 2, say A1 times 2. You remember A1 is 1, 2, 3, 4. 2, 4, 6, 8. And if I do it dot times 2, it is exactly the same. Squaring is different. You have one row vector multiplied by to the second power. It's like multiplying by itself. And this is what I wanted to avoid with not going to matrices. And as I mentioned already, Octave cannot do indefinite integrals. Now you ask me, fine, what happens if that limit is not infinity? Actually, yeah, if that limit is not infinity, but say only 100, it will give me an answer. It will give me a numerical answer, but it's not logarithmus naturalis of 2, natural logarithmus of 2. So if I do that, sorry, let's do it properly. Ans divided by log 2. It's not that, it's slightly smaller. Not much, 0.3%. Now comes something that is very important, functions. I can define functions, I can develop functions, I can use functions. There are functions that are built in the program, and there are functions that I can write. Now these functions have to be I will come to that a little bit later. Let me now define a simple function that is called double one, that takes the argument and doubles it. So I can define it here inside this program very simply. I already have it defined on the screen, but I will type it in function. It is called y equals double one of a variable x. This is a name of the function I will use when I want to run it. And the function is, for example, y equals 2 times x, semicolon, carriage return. This is end. I type end. This is the end of the function. Mm-hmm. It is happy. Mm-hmm. Look, I did not get the double chevron here because I was defining a function. Does it work? Let's do double of 4, for example. Double 1 of 4. Yeah, it gave me 8. Fine. What about double 1 of A1? Remember, that's the vector A1, 1, 2, 3, 4. I just move the cursor out. Mm-hmm. Here is the result. What about double of 2, A2? That was 5, 6, 7, 8. 10, 12, 14, 16. It accepts it. What about if I do double of T1? T1 is to be or not to be? T1. Oh. So what did I get? I will show you this way. I will divide that back by 2. It does not help me, but if I do character.
Okay. But if you feel rough, no.
My answer is to be or not to be. So what did happen? It took the character string, converted the characters into their ASCII numbers, multiplied them, and displayed them because it could not find a meaning to them, displayed them as numbers. To show you that I did not cheat, I divided that result by 2 and asked the program, oh, please, don't display those ASCII number values, but display the characters. Of course, it did it, to be or not to be. That is still the question. Now, but there is a very nice feature that I can store these functions. I can store this function in a file for later use. I don't have to retype it every time. And it's done like this. I created a file called double2, and I just wrote it, function y equals double2 of x, and this is comment. This is what this function is doing, verbally explaining, because next day or next week or in a month's time, I forget what it is about. So in order not to forget, I write a lot of comments. So that function looks like this. And then here is actually the calculation, y equals 2 times x. That's all. In order to be able to do this job, I mean that Octave must be able to find that function. Where did I put it? If you are old enough and used to work with DOS, DOS operating system, you may remember the pass command. Octave and MATLAB 2 use this pass command to tell the software, tell Octave, please look at functions in these folders. So if I type here a command which is called pass, it gives me a long list of folders where it stores the programs. So the various functions that it needs, where the functions where Octave needs to do its calculations. For example, this folder contains some files that are required for plotting. So in order to overcome this problem, I have to tell the software, I have to tell MATLAB, please look at this folder. Now, I did not discuss this. The current directory, when I started the program, is C user Tomy. This is when Octave was installed, it put the default directory there. But I wrote that particular program in a different folder, and that folder is called Tomy Software Octave U3A Communities. So if I go there, click on that, it changed the current directory to there, and I have there 3 files that I prepared earlier. Double click on the first one, and I got, this is pretty small, let me try to make it bigger. Yeah, I have here the function, I call it double2, and it calculates the double value of argument x, and here is the executable command y equals 2 times x, end of function. Now I only have to tell the program, please look at this folder when you want to do a calculation. So back to the command window, and here I click on here, I've entered the command window, I type the command add pass, I put there this folder name, a single comma quotation mark should suffice. Did not complain, that's fine. Let's check add pass, where is that? Yes, here is the very, very first line. First of all, look at this folder when you want to calculate, when you want to use that function double2, just to make sure that it works. Double2, and let's put there, for example, A1, close brackets, return. Here it is. There is, I think, one more thing I wanted to show you. And that is, if you look at me, I have my MATLAB t-shirt on me here. The interesting part, x equals I \b. I was once at a MATLAB conference, and they gave me this t-shirt. So what does that mean? And this backslash operator is used for solving linear equations. That means solution of a linear equation of n unknown of the following type: a x times b. And this is a mathematicians and engineers and physicists recognize this as a shorthand notation for this: a11 x1 plus, and so on. It should be a plus here, plus. A1n equals B1, A11, AN1x1 plus, and so on, and there should be a plus here, ANNXN This is a set of n linear equations with n unknown, where x, y to xn are set of unknown numbers, b is a set of n known numbers, and A is a matrix, is a rectangular array of n rows and n columns of known numbers. So the solution of this equation can be formally written, meaning I can write it. I haven't proven it that it is correct. That mathematicians use it when they are not sure that they are telling the truth, but this time it is pretty okay. X equals A to the power of minus 1b. In MATLAB's, it is written X equal A backslash B. And just let me do a demonstration. And for n equal 1 is solving a linear equation of one unknown. So for example, 12x equals 6. We can calculate that x equals 6 divided by 12. This is 1/2. In MATLAB's, I'd say A, it's n equals 1, so it is a single known number 12, y equals 6, x equals y backslash, sorry, a backslash y gives me 1/2. I can demonstrate it. You can believe me. And I solved one more example, and that's this one. I solved two linear equations with two unknowns. And the matrix A are these coefficients 3, 7, and in the second row, note here, a semicolon, -2, +4, and that's this vector, sorry, this matrix. Y is the right-hand side. It's a it's a row vector 29 semicolon 4. And I write this. Why did it write it twice? I don't know. Once is good enough. And gives me the solution -2 and 5. You can check. This is okay. The last topic I wanted to discuss, or wanted to show, is this can do also graphs or charts. And how? So for example, a parabola. So I define first the independent variable x. It's a linearly divided space between 0 and 10 with 100 points. So 0, 0.1, 0.2, and so on, up to 100. And y, the dependent variable, is its second power. Look at the dot power 2. The next command is figure. Oh, please, create a chart. Plot. Label x. X label. Y label. And grid on. Draw the grid. And you have this chart. It looks pretty okay. Mm-hmm. Now, you can easily create more than one line on a chart, and that's done here. Simply use this hold on command, meaning don't destroy the chart or don't create a new chart. Put everything on that same one. I've done it here. So it can create charts. I think I should stop for 5 minutes, open to questions, because I'm moving to computer algebra.
Well, that's brilliant. So any questions so far? This is certainly more than I knew before. You can put your hand up, or probably there's a few of us, you can probably just speak. You must be explaining it very well, Tommy.
Okay, Peter, can you check if people are asleep?
Yes, I'm watching everyone.
Good, very good.
Oh, they are listening. I'm waving. Look at that.
Good, very good. Thank you, gentlemen and ladies. Now, computer algebra systems are significantly more complicated because they have to know, oh, this is algebra. This is not simple adding numbers or multiplying or raising to the power. It is more complicated, took a significantly longer time to develop, but there is a number of them which are free of charge. You can use them. I am using Maxima. I like it. And when I install it from downloading from the web, I get a couple of files. I forgot to mention Octave comes with a PDF help file, which has, I think, 1,234 pages. If you are not of a strong character, please don't even look at it. Don't touch it. This one comes with 2 more pages, 1,236. Again, it comes with more than one flavor. There is a simple command line interface. There is a GUI in graphic user interface, which is called WX Maxima. I think it has something to do with the old Windows systems that were running on the first Linux or Unix systems. And it stayed there. And I will directly jump into the graphical user interface. It is a little bit more complicated, but it is pretty useful. When you start the program, it comes up with this. And here is the tip of the day. If you are beginners, don't neglect it. Here are some Greek characters. Here are some mathematical symbols. Here are some expressions. Something that helps you to draw history and table of contents. I don't know yet what it is used for. So let me just bring in the PowerPoint presentation so that I can see it. So I bring it here, move here. So okay, I'm trying to do something. For example, x plus 4 to the 4th power. Now I have to tell the software, my dear software, I finished entering the commands. Sorry, let's do it f plus y. I finished entering the commands. For that, in this software, I do shift return. Did it, recognized it, did not complain. I will now expand it. That means x to the 4th power plus 4x to the 3rd power y, and so on. The Pascal triangle, maybe you remember it. So I want to expand it. Expand. A percentage. Shift return. Percentage means use the last result. So it is y to the 4th power plus 4x y to the 3rd power plus x to the 2nd power y to the 2nd power plus 4x to the 3rd power y plus x to the fourth power, exactly as we learned it. Now, if I want to use not the last command, but the previous one, I simply type in I or O and the number. So that's simple. What about assignment? Assignment means something equals to something. It is not equal sign, it is colon. So if I write, for example, x, sorry, I have to be here. X equals 3. So not equals, colon 3. Shift return tells me this variable is 3. And y plus x shift return, well, it substitutes the 3 instead of. And if I want, for example, take the line 3, command 3 to the second power, so the percentage I3 to the second power, shift return. Okay, they did not, because I put the input. If I do percentage O3 here, I hope it will do it properly. Yes. So take the result, the third result, O for output, raise it to the second power. And if I do, for example, y equals, remember, colon 7 shift return, it's 7. What about y over, sorry, 1 over y shift return? It's 1 over 7. But I want it as a decimal point. So you need to use a command float. Float 1 over y shift return. Now it calculates it to 16 decimal points. Good. So remember, colon or equal assignment. Now I discovered recently that I need also assign a kill command. It is called in this language kill, so that y is no longer associated with 7, for example. So if I type kill 7 shift return, tells me 1 done. What is y shift return? I'm not happy about that. Should have done it. I have here a trial, I did it. But I must have done something incorrect. Yes, of course. I killed 7. I did not kill y. So back to here. Instead of 7, kill y, shift return, done. Y, shift return. Yes, it's no longer associated with 7. Looking at there are some built-in constants, and they of course look slightly differently as in octave. For example, percentage pi shift return. Now, why do I write it there? No, that's incorrect. I should be writing here. Percentage pi shift return. Okay, that's pi. I want to know its value. Well, we already know what to do. Type float, bracket, percent pi shift return. Gives me its value. There are some other useful commands. For example, the factor command. I will do the following example. Factor bracket 2 times x to the second power. Why I'm not typing in the proper place? Float. Sorry, a factor times 2 times x to the second power plus 3x plus 1. So that was the expression in the integral I had in the MATLAB case. So if I factor it, shift, return, incorrect. Okay, you see my error was I did not type 3 times x. I typed 3x. Again, shift, return. Oh yes, it's unhappy because I left x with a value of 3 if I mistake, shift, return. So kill x. Done. Let's go back to this command. Factor this. Oh, it factored that second order, that parabolic expression into x plus 1 in brackets times 2x plus 1 in brackets. This is what I wanted. And possibly it's good that I make mistakes because I show you what can happen. You simply forget. I forget to put there a multiplication sign. It also is pretty good in solving equations. And for that, it has a solve command. And it can, because it is solving the equations algebraically, it has a significantly wider range of problems it can solve. For example, I better show it in my PowerPoint presentation. The solve command. Here in this command, I define by equality or set by assignment sign 3x equals 4. You see, I defined equation 1 or ec1 is this equation. And I want to solve that equation with respect to x. Well, it gives me x equals minus 4 over 3. And it puts it into square brackets, indicating it is a list. List meaning it is a variable which can have more than one value. And that becomes important when I try to solve this parabolic equation. You may be familiar with it. 2 times x to the second power plus 3x plus 1 equals 0. And then it writes it out and solve it with respect to x. So one solution is x equals minus 1/2. The second solution is x equals minus 1. This is a parabolic equation. It has, in this particular case, 2 different solutions, both of them real. And it can do differentiation. It can do a Taylor series of an expression with respect to variable x at point A up to the nth order. For example, the Taylor expansion of sine 2x with respect to variable x at point 0 at the origin up to the 5th order. So this is the first order, the second order is 0, the third order, the 4th order is 0, and the 5th order is this one.
Is that, sorry, Tommy, is that the slide truncating it there? Is that what the answer you actually get?
Yeah, no, it's not truncated. I told him how many terms.
Oh.
I truncated it. I think it would complain, but it happily does. I did sometimes 10th order, and it happily does it. Then, of course, the expressions become more and more longer and longer.
Mhm.
And I want to show you this example, definite and indefinite integrals. And because it can do symbolic calculations, it can do the indefinite integrals, meaning no limits. So if I do that one, I have to do, integrate this function, that is 1 over 2 times x to the second power plus 3 times x plus 1 with respect to variable x. That's representing this dx with respect to variable x. And the result is logarithmus 2 times x plus 1 minus logarithmus 2x plus 1. So you know difference of logarithms is ratio of the numbers inside. And if I ask it to do that integral, to integrate from 0 to plus infinity, I get the expected results log 2, logarithmus naturalis. These two slides are introducing verbally what are these things, and an example here. And when exiting max, wx max, it asks you, do you want to save the changes you made to the document? That means if you want to save the log file of what you have been done, so what you have been doing so far, you can save it. You don't have to, and you can cancel and continue to work. If you save it, it asks you where to write it, and you'll get an XML file. This all your commands, you can edit it and reuse it next time. And that's practically everything I wanted to say. There is even an appendix here. If the Octave GUI does not work properly, it's a operating system, at least on Windows 11, it's an operating system problem. Fix it this way. Change setting to here. It's described here. And it is possibly a good point for me to stop talking.
Well, I think that's brilliant, Tommy. I mean, can you give us a bit more of a feel how you would use this in practice? Let's say you're doing some numerical work on some real world data. You know, maybe you've got 1 million data points to import or something like that. How would you use that for numerical computation? Presumably you can do that sort of thing rather than typing all the numbers in yourself.
I'm now I will now give you an example that I spent most of my working life not solving, but using that piece of software that I inherited and then developed over my working life. I spent all my working life, meaning not in industry, not at university, but in industry, developing MRI magnets. And the MRI magnet has to have one property. That means the magnetic field has to be very, very, very homogeneous. And how do we achieve that the magnetic field is homogeneous? We measure the magnetic field on surface of a sphere inside the imaging volume. Typically, we measured it in 144 different points. Don't worry, this wasn't done in later stages of my life. Manually, we had an automat that did it. and it provided me with a matrix with a rectangular array of 144 numbers. Now the boss told me, now go and make this magnet homogeneous. And I had about 12 or 14 or 16 knobs to turn to adjust the magnetic field to homogenize the magnetic field inside, on the surface of the sphere. And the theorem in mathematics told me if it's homogeneous on the surface of the sphere, it will be also homogeneous inside. That's a law of mathematics, and you can't break a law of mathematics. That's not politics, that's mathematics. So this is what happened. I measured, passed it through the software number crunched these numbers, this 104, 12 times 12 is 144 numbers, and told me what I need to adjust. I adjusted, did a second iteration, did a third iteration, and typically after 2 iterations, I achieved the required homogeneity on the surface of the sphere, and the boss was happy. That magnet then could go for shipping to the customer. So this is an example. We thought that with a pocket calculator, it wouldn't be possible to do.
Mm-hmm.
Stop sharing.
Yeah.
And this is one of the examples. Many engineering projects require a huge amount of calculations. These are done by similar ways. A model is written, mathematical equations are set up, and then people use it. It's the scientists who write the programs. Usually it is a scientist who writes it himself, the program, because it's a mathematical program. It's not left for software engineers. Software engineers package it for the proper user interface, and then it's used by people who have to use it. And the day I got this T-shirt, I was in Silverstone at a seminar. MATLAB is organizing once a year an open day, and brings some customers to show their favorite cases. And I was sitting there with my mouth open and listening that a Jaguar Land Rover are accepted MATLAB's software, and practically the whole factory, except purchasing, which is a completely different animal, except purchasing, the whole factory, whole MATLAB is running on one software platform called MATLAB. And MATLAB has this marvelous feature that you can push down freshly developed software to people or departments who use it. And if there is a problem, they report back to you. So there is a high degree of reusability. And Peter, you come from the software part of these things, and reusability is one of the most important parts in software development. You don't want to develop something the second time.
Absolutely. Get it right first time.
Get it right the first time. Have one software for that particular function, have one, and not that every scientist invents his own software. No. So, ladies and gentlemen, if you have any questions, please get in touch with me. I should be able to answer some of them, not all of them, but some of them.
Well, I'm not seeing any questions here. Not even from Peter. Peter's asleep. Oh, I've woken him up.
No, you haven't. I was awake all the time. I'm just taking it in. It's clearly, I think your question is a good question. Is how do you focus this around an example? Really, that's the key to it. Anything you're doing. You need to then relate it to something in the real world, which I would say real your world, an individual's world,
Mm.
rather than not esoteric, but not academic even, but a theoretical model. So that's what I'm struggling with most of all. How do I relate what Tommy says today to something where I have a need? And that's quite a difficult thing. I'm finding it a difficult thing to do, Peter, if I'm honest, actually.
Yeah.
I can't think of a problem where I would need this level of skill, which Tommy's clearly got tons of it, tons of skill. I'm trying to figure out how that where I'd apply that to. Obviously, in his profession, he had the job of clearly selling. Well, this company sold some sort of magnetic device which produced an exact sphere of a magnetic sphere. That was clearly a very good use of it. Is there any other examples where you found it very useful, Tommy?
Well, every engineering design, to design a bridge, you have to do calculations. You have to decide what will be the size of the trusses.
Yeah,
Everything that you design, you have to give an estimate. Okay, look, this is a minimum I need. I need a safety factor. This will be the wind factor, and so on. So that everything has to be built in. And eventually, you end up with a very complex calculation.
yeah, yeah, yeah. So basically, if you were the classic model I have in my mind of how, say, a building is produced or developed. The architect, in my mind, produces something which I think one might use the word visually appealing, or might have an artistic aesthetic. There is what the architect produces. Then it gets passed to consulting engineers in my model, which they then take and say, how on earth can we make this shape in a safe way? And that's when all this stuff comes into play, doesn't it? Is what you're saying to me.
Yes, yes.
Okay.
And
Okay.
they don't work separately. The best designs is when they work together. Look, I need here that thickness, but here is that is enough with all
Yeah.
the safety factors.
Yeah.
So
Sure.
they need to work together.
And of course, the material science comes into play as well, doesn't it? Quite a lot of it. Each material will have its different characteristics. So I can see where the maths comes in there. If you've got a different material, then clearly the mathematics associated will be different depending on the
Yes,
material.
yes. Look, you may notice last month was a disaster in Sarajevo. I think it was in Sarajevo, where on the railway station, decoration fell down after 35 years being up and being the proud of the town. It fell down because when it was built, designed and built, people were not aware of fatigue in fiberglass.
Yeah, 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 yeah.
I
So
did not go and recalculate it. Somebody had a look at it and said, yeah, well, one day it will fall down. Because by then, 30 years later, he had the experience. These things have a finite life.
yeah, 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 yeah. I understand what you're saying. It is so, and modern architecture is so well. It's quite beautiful, but it also is very complex in terms of what you can build and can't build, isn't it? Really?
Yeah, I can give you another example, Peter, from the other side of the fence, if you like. I mean,
Yeah,
I've worked in the city on stock markets, and what they do there is they have a job role which is called quants, and these are the mathematicians that use all these sorts of tools like MATLAB and R and so on, and figure out how the stock market needs to work. And they do all their work in their sort of mathematical area, and then they
yeah,
over the fence to the software engineers who actually deploy it and make it work with the.
Yeah.
So it's a bit of a teamwork. You can't expect the software engineers to understand all this mathematical modeling. You can't expect the mathematics engineers to understand the software side of things.
Some of this is extremely complex, isn't it? Really. Yeah. And obviously, what we've got is a lot of specializations depending on the nature of the object you're trying to produce. I talked about buildings, and as Tomy said, bridges is another one. But obviously, another one will be weapons where you're trying to build an explosive to do something. You have to focus that energy in order to be more effective. There's another example of heavy computational uses, actually. Yeah. Anyway, I've talked enough. It's fascinating stuff.
Yeah. Oh, I agree.
Thank you, Tomy. Thanks for your presentation, Tomy. Thank you.
You are welcome.
Yes, I think that was really interesting. It's something different and that we've not covered before. So I'm really quite appreciative of that. Any other questions then before we sign off? We're coming up to the half hour, which we normally finish on.
If I can make a comment and a question. As an example, back in a previous life, I used to teach A-level mathematics. It would have been great to be able to check all of my answers before giving them to the pupils, the students. On the other hand, it might have been a nightmare, I think, if I thought, oh my goodness, they've used MATLAB or whatever to produce their answers. It's the sort of thing that a lot of teachers are having a problem with now with AI. Very much the same sort of thing. On a different tack, with the Raspberry Pi, you get Wolfram for free, which is another set of software similar to what we've been looking at. Do you have any experience of the?
No, I did not have access to Mathematica, which is a Wolfram software, and I know it is the gold standard for computer algebra systems. Maxima is sometimes less sophisticated. If you can, it's very, very expensive. If you can get access to it, it's great. It's a great software.
Yeah, the point was that with the Raspberry Pi, you get it for free.
Yeah.
I wouldn't pay for it.
Yeah, but it's limited because Raspberry Pi is rather limited. But coming back to your question, that integral I showed, that's an integral from A-level maths. My grandson sent it to me that he needs help, and 2 minutes later I got another WhatsApp message. Yes, I solved it. And then I had a look at it. Yes, well, it is actually reducible. I just share for a second my screen. It is reducible to two simple elementary integrals. Once you know how to divide this expression into two partial fractions, and I did that here. Yeah, I did that here.
Yeah.
So yes, answering your question, yes, you can use this software to check your results.
Excellent. So I'm not seeing any other questions. It's pretty much 1:30, so let's call it a day then. So thank you again very much, Tomy. I do appreciate this. And
thank you.
Happy Christmas. Happy New Year.
Thank you. Happy Christmas. Happy New Year. See you next time.
Thanks very much.
Bye.
Thank you very much indeed. Bye-bye. Bye-bye.
New Year.
Bye. Thank you. Thank you very much.
Yeah.
Bye.
Excellent.